Let's imagine that a new creature has been discovered on an unexplored island. A team of scientists is sent to investigate the creature and decide to call it a blob after its rather gelatinous form. They soon find that blobs come in two colors, green and purple, and that the color of a blob is coded for by a single gene with two alleles, an allele for green skin and an allele for purple skin. Blobs are also diploid, so they have two alleles for each gene, one received from each parent. If a blob has two of the same allele, only that allele trait is expressed. If a blob has both the green and purple allele, only the dominant purple allele is expressed. Now the scientists are curious if the population of blobs is evolving towards a particular skin color. To solve this puzzle, the scientists can use what is called the Hardy-Weinberg principle. The Hardy-Weinberg principle is made up of two parts. The first is a prediction about how alleles are distributed in a population. For example, if you know that 37% of all the alleles of the blobs on the island are green, then the Hardy-Weinberg principle can predict what percent of blobs should be green and what percent should be purple. The second part is the prediction that the frequency of an allele, or how common it is, should stay constant across multiple generations. These predictions only apply to populations that aren't evolving, but scientists can measure the variation of a population from the predictions in order to spot evolutionary trends. Well, let's drag in the equations. This P and this Q represent the frequencies of the purple and green alleles respectively, both of which will be expressed as decimals. This top equation is just fancy math speak that says that the frequency of the alleles should add up to 1, like how all the slices of a pizza add up to one pizza. The bottom equation is just the top equation squared. The three terms of the bottom equation correspond to the three different possibilities of alleles, or genotypes, a blob could have. The first step is to fill in all these terms. This is usually done in dominant recessive alleles by finding what fraction of a population exhibits the trait of the Q-squared term, or in this case, green skin. Using some algebra, the equations will spit out a prediction about the frequency of genotypes. This can be checked against the results of a genetic testing of the population. Any discrepancy here is usually caused by selective mating or inbreeding, but since the two results match, confirming the first prediction, the scientists will have to record the P and Q values across multiple generations and look for fluctuations. In this case, there's a clear increase of the Q value, which as you'll recall represents the frequency of the green allele. This tells scientists that the blobs are evolving to favor green skin over purple skin. This could be due to natural selection, migration, or even just random chance. The scientists will need more information to find a definite answer, but for now, they could use a break.